Hi, welcome to part 3. We are on problem 8, which gives us a demand function for a new game. So this means X is the price, and Q, or D of X, is the quantity that people buy. So here's our elasticity of demand formula. You don't have to memorize this. It will be on the test just like it's on here, of course. We want to find that. So first I'm going to find D prime, because that's the hard part. So D prime of X. So I'm going to write it over here to the left. Remember that a square root is just something raised to the 1/2 power. This seems to cause a lot of confusion, but it's not so bad. Okay, so we have 1/2 200 minus x cubed to the negative 1/2. Then we need to use the chain rule, because notice in here we don't have x, we have 200 minus x cubed. So we need to multiply by its derivative, so that is negative 3x squared. I'm going to go ahead and simplify this because it's going to make the elasticity function much easier to work with. So when something is to a negative power, that means it's on the bottom. And it's going to be to the 1/2 power, so that's a root. So 200 minus x cubed. This 2 goes down here, and this negative 3x squared can go on the top. Okay, now I need to plug this into my elasticity formula. I have negative x times this whole thing we just figured out. The denominator is 2 root 200 minus x cubed. The numerator is negative 3x squared, all over d. So d is root 200 minus x cubed. Okay, these two negative signs are going to cancel each other out. So we're going to get 3x cubed over 2 times root 200 minus x cubed. And then I'm going to turn this denominator into 1 over 200 minus x cubed root. When I multiply these two square roots together, they're going to turn into a not square root. So that's going to give me 3x cubed over 2 times 200 minus x cubed. I can't do any canceling because the x cubed here is in a part of a sum, so I can't cancel it with that x cubed up there. But that's my answer. Okay, find the elasticity when x equals 3. Well, that's no big deal. That's 3 times 3 cubed divided by 2 times 200 minus 3 cubed. I'm doing that on my side calculator here. I get that it's approximately 0.234. Part C asks us at x equals 3, will a small increase in price cause the total revenue to increase or decrease? So look, the magic number, the magic elasticity is equal to 1. This is less than 1, so it's low. Low elasticity of demand means that the price doesn't affect demand very much. So raising the price will get more money. Will increase our revenue because people won't really buy that much less, but we'll be charging them more for it. So that's good for us. And then the price that maximizes revenue for part D is this magic elasticity. So we need to solve this formula. We need e of x equals 1. So that is, sorry I keep forgetting this, 3x cubed over 2 times 200 minus x cubed is equal to 1. So let me continue the algebra over here. I'm multiplying both sides by the denominator, so I get 3x cubed is, and I'm going to go ahead and distribute this, minus 2x cubed. That tells me 5x cubed is 400. That tells me x cubed is equal to 80. And that tells me that x is the cube root of 80, also known as 80 to the 1/3, which my calculator says is about 431. All right, next page. Antiderivatives. This is the other really important part of the exam. Okay, antiderivatives, we're looking for a function that gives this function as the derivative. So the function that gives 2 as the derivative is just 2x plus any constant c. We always need to add the plus c. I will take off points if you don't have the plus c. All right. So 1/2 x, we need to raise the power to 2. And then we need to divide by that power. So we get 1/2 times 1/2. So this 1/2 comes from here, and the other 1/2 comes from the rule. So that's 1/4 x squared plus c. If you're forgetting the rule is that x to some power, when you take the antiderivative, is the opposite of taking the derivative. You do x to the n plus 1, and then you multiply it by 1 over n plus 1. In other words, you divide by n plus 1. I don't know how that one got so tall. Okay, here we go, 3x squared. So we have 3, that's the same 3. And then we have x cubed, I'm using the rule now, and times 1/3. The 3's and the 1/3's go away, and that just becomes x cubed plus c. Alright, when we have a sum, we just do each part. So x squared, by my rule over here, becomes 1 over 3 x cubed. My 7x becomes 7 over 2 x squared. My 2 becomes a 2x. And then I get a plus c. I guess I could write the rule for constants. If you just have some constant dx, you get ax plus c. You can remember these rules, or you can do these by thinking about how to get this as a derivative. So if you take the derivative of ax, you get a, right? The derivative of 3x is 3. That's how we're doing it. Okay, 3 over x, we need to remember that the derivative of natural log is 1 over x, so this is the rule. 1 over x dx is natural log of x plus c. The 3 just gets multiplied in, so we get 3 natural log of x plus c. Here we have e to the 2x, so what do we need to differentiate to get e to the 2x? We know we'd have an e to the 2x because that exponent never changes. There's going to be a plus c. And the 2x, if we took the derivative of this from the chain rule, we'd have a 2 in front, but we don't, so we need a 1/2. So there's a rule that goes with this. The antiderivative of e to the ax dx is e to the ax, but we multiply by 1 over a plus c. Okay, next problem is root x. Some of you are really pained by roots. Square root is just 1/2. So we use that same rule up there. We add 1 to the power. So 1/2 plus 1. Here, I'll write it. 1/2 plus 1. 1 over 1/2 plus 1. That looks silly, so 1/2 plus 1 is 3/2. And 1 over 3/2 is 2/3. 1 over any fraction, you just flip it over. Oops, look at that. I forgot to add the c. Points off for me. Okay, x to the negative 3/4. We need to just add 1 to the 3/4, so we get x to the 1/4. Then we need to divide by the 1/4. That's the same as multiplying by 4, plus c. Okay, number 10. Find f such that f prime is x minus 3 and f0 equals 2. This is an initial value problem. Okay, so if the derivative of f is x minus 3, then f is the antiderivative. So f is an antiderivative of x minus 3. So the x becomes 1/2 x squared. The 3 becomes a 3x, and then we have a plus c. What we use the initial value for is to figure out the c. F of 0 equals 2 means 1/2 times 0 squared minus 3 times 0 plus c is equal to 2. These two things are 0, so that tells me c is 2. So f of x is 1/2 x squared minus 3x plus 2. Okay, next problem. Marginal revenue. A marginal thing is always a derivative, and we want the total revenue function, so that's going to be the antiderivative. So r is the antiderivative of x squared minus 3 dx. So that is 1/3 x cubed minus 3x plus c. But I want the actual function. Plus c doesn't tell me a function, it tells me a whole class of functions. I'm going to assume that r of 0 equals 0. I'm going to plug in this initial value of 0 because I'm going to say, if I'm not selling anything, I'm probably not making any money. That makes sense to me. So that tells me that 1/3 times 0 cubed minus 3 times 0 plus c equals 0. That tells me that c is 0. So overall my revenue function is like this. 1/3 x cubed minus 3x. I'm not going to write plus 0 because that's silly. There we go. Okay, the next problem is a sum. I equals 1 to 3 tells me I have 3 parts. So I have an I equals 1 part, and I have an I equals 2 part, and I have an I equals 3 part. Then I just plug in 1 wherever I see an I for each part. So here I is 1, so this is 2 to the 1. Here I is 2, so this is 2 squared. Here I is 3, so this is 2 cubed. So this is just 2 plus 4 plus 8, which is 14.